Okay, so I am Javi. I am a front-end engineer, and I work here at New Relic. Let's go to the point. I'm going to talk about SVG icon systems. So this talk consists in 3 different parts. The first one is prerequisites that you might want to take into account before building an icon system. The second one is different techniques to render SVG in the browser. And the last one is building the proper system. So let's start with the prerequisites. And one of the most important things before building a component system is the visual proportions. Each icon is different. They have different size. They have different stroke width. They have different radius. And in this case, I mean, if you're using just a single icon, it doesn't matter. But when you're building a system, you're using a whole set of icons. So we need to take into account the proportions. They should be all well balanced. In this case, we can see how this icon or this one might look bigger than the other ones. And we also might appreciate that the moon icon, its stroke is thicker than the rest of one. So if we want to balance the proportions of the icons, it will look something like that. So sizing is another important thing. We want to be able to change the size of our icons, and even more, we want our icons to inherit the font size that the parents are defining. So in this case, we are rendering an inline SVG, and we are just setting the width 1em and height 1em. If I remove those declarations, what happens is that we don't see anything, because the SVG by default takes the full width and height of the parent. So what happens if I define a width here? Okay, so now we see the SVG, but it takes almost the whole screen. So if we set the width to 1em, and removing the width and the height, we can ensure that our icon looks properly. But if we have SVG with heights and widths, then we need to override the defined width and heights in the SVG. So something like that, we can get our icon properly scaling as we want. If we use CSS backgrounds instead of inline SVG, we are basically defining the background image here as a data URL, and we are using background size 1em. So what happens here? We have said before that SVG takes the full width and height of the parent, but in this case, it's overflowing. So if we check the SVG, we can see that there is a width and a height defined. If we remove them, it will be properly scaled. But it's safer to use background size em, because you could have SVG icons with sizing or without sizing. So in this case, it also scales properly. So next thing, coloring. We want our icons to be colored the same way we scale them. We want them to inherit the color from their parents, and we want to manually change their color. So in this case, we have the regular SVG, the inline SVG. By default, it's black, but it's black because there is no color defined in the SVG, so it inherits the color of the body. So if I use fill current color, we get the proper color that we are defining on the parent. But what happens if the SVG has a field defined? Okay, we see that the field we have defined, it's overriding the current color field that we have defined in the icon. So in this case, we specifically need to target the elements inside the SVG that are defining the fields. So it's safer to just style all of them, all the possible elements in SVG that could have a field color, and you are safe. And we can see how it worse, and we got rid of this red color there. Well, another important thing in an icon system is aligning. By default, in this case, we are using basically Helvetica, a text with an icon on the left, and we are using flexbooks. We could use display inline block and vertical inline middle, and it will look the same way. But what's the problem with that? This is not very robust. So if you might know that the typographies could have different line heights. So in this case, we have Helvetica. These both typographies are rendered at the same size, 129, and Helvetica, the line height is 150, and in Papyrus, the line height by default is 199. So there's a big difference. So if we check the same example, the same example we have seen before with the Papyrus font, what will happen? We can see the alignment is broken, right? So how can we fix that? Because the elements are properly aligned. I mean, if I set on line, sorry. I mean, the red box is properly aligned in the parent box. So how can we fix that? So first, we need to know the unitless line height for both the icon and the type. And in the case of the icon, the font size is equal to the line height, so the unitless line height is 1. In the case of the typography, the font size is 129, and the line height is 199. So to get the line height, the unitless line height, which is the relative, we need to divide the line height by the font size, and we get 1.54. So icon line height 1, and the type 1.54. So we have a difference of 0.54 to distribute across the parent box of the text. And this is something that we need to make visually, because there is no way to, well, there's ways, but not easy to do that with math. So we are basically distributing this difference across the whole space that remains here. And we can see it working. And if we remove the red color for a transparent color, it just works. On the align, I mean, if we scale the thing, this is properly aligned with the text. Okay, so now that we have the main prerequisites of our icon system, let's go into the different techniques that we know to render SVG in the browser. So the first one, as we have seen before, is inline SVG. We are defining with 1M, as we did before. We are overriding the size of the SVG also, and we are ensuring that the paths inside the SVG are properly colored. So in this case, with inline SVG, we can see that it scales properly, and the color is changed, it inherits from the parent properly. So, good choice. If we move to the next technique, we have SVG symbols. SVG symbols are basically SVG files which contain other SVG elements, but they are inside symbol tags. These symbol tags are not rendered, but you can reference them from another SVG using the use tag. What happens in that case if I override? I mean, in that case, like in inline SVG, it scales properly, so we are inheriting the font size, and it changed the color properly, so we are inheriting the color too. And this is nice, but what happens if the SVG we are using, the symbol, contains a fill, like before? Okay, in this example, I am rendering the first one. I am referencing the local symbol that I have defined before and corresponds to that icon. And in this SVG, I am using an external SVG file. Okay, so I have defined a fill here, fill color, and we can see that this current color it stopped working. So you might think, oh, okay, let's override the color of the path with important. And this doesn't work. And it doesn't work. When using symbols with the use tag, you cannot override I mean, if the SVG in the symbol has no styling, it will inherit the color from the parent. But if the symbols have some styles, like this one, you can override them. You cannot override them from outside. Okay, next one. SVG sprites. So SVG sprites are basically like the old bitmap sprites that we were used to do in the past. This is basically a SVG, which contains the same icon multiple times. And each time it has a different color. So if we want to change the color, we just offset the background position. In this case, we can see that this technique is not inheriting the color from the parent, but it does with the font size. But if we hover, we see we are changing the color, and that's because the icon I saw before has the two colors. And here I am defining a hover, which displays the background. So that's why when I hover, I see the icon in the right of the sprite. Next technique, SVG as a CSS background image. So this basically, at the first look, it scales properly, but there is no way to color a background image from CSS. And there is nothing we can do here. I mean, we can, but we will see it later. So this doesn't work for us because it doesn't with our prerequisites we have seen before. Another alternative is just rendering the SVG as an image tag, but we have the same problem that before. If we want to change the color, it doesn't work because it's a separate document, so we can affect the styles there. But if we change the font size, it scales properly. I really like this option. This technique is basically CSS masks. So in this example, we are basically defining a box. For the background color, we use current color, so it inherits the color defined in the parent or in itself. And if we change the color, we can see how it changed the box. But now, if we add the mask, and the mask is basically the icon you want to render, and it's black, so it acts as a mask. And we can change the color of the parent, and we can see how it perfectly works. So good choice. Well, good choice, but it's not supported in Internet Explorer, so we can use it. So now that we have seen all the different techniques, we have seen that inline SVG works. We can color it, we can scale it. There is no problem with that. Then we have SVG symbols, which also works, but we cannot override the styles if they are defined in the original SVG. And if we want to include external SVG symbols from a URL, it doesn't work in Internet Explorer. But there is polyfills. You can use SVG to everybody or something like that. Then we have SVG sprites, which is nice because we can scale them. We can change colors, but non-dynamically and not in runtime. We need to define the colors before using them. And then we have CSS masks, which are not supported in Explorer. So we have seen that we can't change the color of when the SVG is used as a background image. We cannot change the color when the SVG is used as an image tag. But is that true? How we make them work? I mean, I want to change the SVG color when you use it as CSS background. So the solution is basically using URL encode data URLs instead of base 64. And this has several advantages, like it's better for the shipping, for compression, the strings are sorted in when URL encoded versus base64. And in the context of this talk, sorry, in the context of this talk, what I really like from URL encoded strings is that you could manipulate them in SAS, for example. You can perform a string replacing in SAS. So we could inject some style tag here and change the color inside. Let's see an example. So here we have a map with two different icons. The icons are URL encoded, and we have added a placeholder at the end before the SVG closing tag, so we can replace that string in SAS with a style tag. So here basically have a string replacing function, then we have the function that is doing the work. So we are getting the template. The function accepts the name of the icon and the color you want. So we get the template from the map, and we just create the string with the styles. We need to URL encode these two. So we basically are creating a style tag, and we are saying the circle, the ellipse, the line, the path, the polygon, they have fill with the color you have with the color you have provided here. Okay, and then we just use the string replacing function and replace the content of the template. We replace the placeholder in the template with the content of this variable. So what we get is something like that. Okay. So here I am using the icon URL mix function, and if I change the color here, sorry. So it's basically, we are basically generating the whole SVG from scratch and using it as a background image. So the problem of that is that every time we render an icon with this technique, we are generating a new SVG file, so this is not very optimal. Let me go back to the slide. Oops. Okay, so let's build the system. The first system is basically using SVG sprites, but we want to use them as CSS backgrounds, and we want to generate them in SAS, so we don't need JavaScript for that. So this is how a sprite looks like. We need to generate a single sprite per icon, and then we have one column in the sprite for each color. There is no icon here because we have now defined a blue color for the cloud icon. So all the icons should match the columns with the proper color. So this is how it looks in code. We are basically creating the symbol, the SVG symbol. We are referencing the symbol from here and from any cell, but we override the styles of each use tag with the color you want to use. This is how a sprite looks like. Is the SVG. It has a defined width and height, and then we define the symbol, which is a simple path with a star, and then we generate different styles. The first one, we just say all the paths inside the SVG should inherit the color from the parent, and then we just generate a new style rule for each SVG that are the real icons here. So I am adding a class to each SVG, and then I am generating a style tag which targets that class and overrides the color. So we can see black, blue, and red. And we can see here black, blue, and red. So we got this SVG image with all the colors. Let's see how this works at the scale. So in this case, we are generating the sprite in SAS. So it's like in the sample I saw before, we have templates, but instead of having just the placeholder, we also have a placeholder for the width and a placeholder for the height. Because depending on the number of colors we want to use in our icons, the width of the sprite will change. So we need to replace this placeholder by the final width of the sprite in SAS. So it's basically the same, but it works different. We have the string replacing function, and then we have a color symbol function that it generates the style tag for each nested SVG. Then we have a function that takes the map, and it basically creates a new map, but with the final SVG. I mean, with no placeholders and with all the values replaced. At the end, the important thing here, you can look at the code before because we don't have more time, but how I use that. I basically iterate over all the icons that I have defined in the map at the top, and I generate a SAS placeholder selector called icon dash dash and the name of the icon. This means that the good thing of placeholder selectors is that they don't output real CSS in the final bundle. So we can have them. If you use it, it will be in the output, but if you don't use it, it is just gone. So icons, here defining the main icon class, and then we are defining the icon star and the icon cloud. To render the icon star, we just extend the icon star, because as we have seen before, it's the one which is specifying the background image. And then we can see we are changing the color of the icon in the hover, just saying, okay, if there is an icon here, I want the red one. And in the active state, we are doing the same, but we want it blue. So if we came here and we hover, we have different colors. And if we press over one of them, there is nothing here, but there is something here. Why? Because the implementation. I am defining. You could define the base colors that you want by default, and then you can override per icon. In this case, in the cloud icon, I am telling that I want it blue too. But in the case of the star icon, I don't have it blue. And here you have an example of all of the proper system. You have all the icons here. Obviously, they don't react to the color change, but we have hovers, and we could have other colors too. And the last one, this is short. This is if you are building React components or something like that, you might probably want to use that technique. It's basically instead of generating a template and injecting it in CSS, we could just generate a JavaScript module which exports any icon as a string. The good part of that is in the future with this tree shaking concept, you will just get in your bundle the icons you use. And how we use them, it's basically another React component which receives two props. The name, which could be any of the keys in the icons map,